All right, so today we're going to begin our discussion of drawing free body diagrams. So we have the D01 worksheet here, drawing free body diagrams. And the instructions say, for each of the following situations, use the following symbols to identify the forces in your diagrams. So applied force is F ap, air resistance is F air, force of gravity is Fg, normal force is Fn, tensile force or tension is Ft. In aeronautics, so anything that has to do with anything flying or whatever, applied force is known as thrust. Okay, so if something says thrust, we'll know that that's the applied force. Air resistance is known as drag, so if that's mentioned. And the upward force is known as lift. So instead of normal force, we say lift. Okay, so we're going to convert all of those when we're talking about flying objects. Otherwise, an applied force might be if you push something or pull something or drag something across the ground. Okay, the normal force is anytime something is resting on something else, so a car on the ground or a book on a table or you standing, that's all going to have the normal force acting in the up direction. And then if anything is suspended or dangling, like a backpack or a purse, that's going to be tensile force or tension. Okay. All right. So for number one, it says a book lies on a level table. All of our free body diagrams are going to start with a simple square that represents our object. Okay. So a book can be a square. Okay. You are going to be a square. Everything is going to be a square for the free body. Okay. A book lies on a level table. So there are two forces acting on this. It is at rest, so there are only two things that are going to have to be equal to each other and cancel out. One is the force of gravity that's trying to pull it down to the ground. So our force of gravity is Fg. Okay? The only thing that's preventing it from hitting the ground is the fact that it's resting on the table, which means that in the other direction we have the normal force. Okay, so our Fn. So our normal force is acting in the up direction, gravity is acting in the down direction. So this is our free body diagram. It is just as simple as that. Okay. Number two, now we're taking a book, could be the same book, being pushed at a constant velocity along a level surface. So again, we are going to start with our free body. Our book is just going to be a simple square. It's our free body. Okay, it says consider friction. Okay, so it's being pushed. Okay, so anytime you see pushed, we know that we're going to have an applied force. So I'm pushing the object. So that's my applied force. Okay. Friction is acting in the opposite direction. So the force of friction, okay, is going to be acting in the opposite direction, and we'll just call that F sub F for F friction, okay? And then again, gravity is always acting down, okay? So we're always going to have that force of gravity, and then to counter the force of gravity, we're going to have the normal force. Okay, so when it's just at rest, we have a normal force in the up direction and the force of gravity in the down direction. When it's being pushed, we have an applied force in one direction. The force of friction is opposing that direction. Force of gravity is always acting down, and the normal force is always acting up. So that takes care of questions 1 and 2. Moving on to questions 3, 4, and 5. So it says a girl holds her purse by one strap on her shoulder. So one strap, that's key. This means we're going to have one force that is from where it's suspended. Okay, so if it's suspended from her shoulder, okay, that means that we've got a tension force. Okay, so force of tension, okay, tensile force. Okay, and we have the force of gravity that's acting down on it. So F of G going down, force of tension going up. It's not falling, so those two forces cancel each other out, and it stays suspended on her shoulder. Okay? A person floats in a pool, so they're not sinking to the bottom. They're floating in a pool. So again, we've got the force of gravity acting down, okay? But the normal force in the up direction cancels it out. Okay, so they are floating in the pool. It's just like laying on the ground. Okay, the person is floating in the pool. The force acting in the up direction is equal to the force of gravity. Okay. Now for number 5, we have a dad pulls his child in a wagon on level ground. Consider the child and the wagon as a single body. Okay, and then it says consider friction. Okay, so this is the child inside the wagon. So the child inside the wagon is the same as is just one body put together. Now, there is an applied force because the dad is pulling on the wagon. So now remember, the dad is going to be taller than the wagon. Let's assume, let's hope. So that means that the applied force is going to be going at an angle both up and in the direction that the dad is pulling. Okay. There is also, of course, the normal force because the wagon is on the ground. So we have the normal force acting in the up direction. And then we also have the force of gravity acting in the down direction. And then remember, we have to consider friction. Okay, so there is friction that's acting opposed to the applied force in the direction behind the wagon. So we have the force of friction going in that direction.